We are doing the 2023 ISI B.STAT paper. This is question number 10. So here we are asked to find the limit of an expression which has power of n to the power minus 3 by 2 and the whole expression of n plus 1 to the power n plus 1 etc. to the power 1 by n square. So wherever you have n or function of n in the power, you have to start by taking log. So let the whole expression be equal to x. So x is equal to n to the power minus 3 by 2 times n plus 1 to the power n plus 1 times n plus 2 to the power n plus 2 all the way up to 2n to the power 2n can be written as n plus n to the power n plus n. So there are n terms in this product to the power 1 by n square. So if I take log on both sides, I get ln x equals ln of the whole expression, which is minus 3 by 2 ln n plus ln of the entire expression, which means 1 by n square times n plus 1 ln n plus 1 plus n plus 2 times ln n plus 2, and this will continue up to n plus n times ln n plus n. So this can be written like this: ln x equals minus 3 by 2 ln n plus, you take 1 by n inside, so you have 1 by n outside, times you take 1 by n inside, so you get 1 plus 1 by n. Ln of n into n plus 1 can be written as ln of n into 1 plus 1 upon n plus 1 plus 2 upon n times ln of n into 1 plus 2 upon n, and this will continue up to n terms. So the last term will be 1 plus n upon n ln of n into 1 plus n upon n. So this can be written as a summation: ln x equals minus 3 by 2 ln n plus 1 upon n summation of 1 plus k upon n into ln of n into 1 plus k upon n. So this is the summation where k goes from 1 to n. So now you expand and simplify this. So you get ln x equals minus 3 by 2 ln n plus 1 upon n times, you are multiplying 1 plus k by n. You expand ln of n into 1 plus k by n, so you get ln n plus ln of 1 plus k upon n. So you get ln x equals minus 3 by 2 ln n plus, you multiply the first term with ln n and you have 1 by n, so 1 by n into there is a summation that has been missed out, so there is a summation here, n equal to 1 k equal to 1 to n So you get 1 upon n into ln n, since n is not dependent on k, into summation of k equals 1 to n into 1 plus k upon n, plus you get 1 upon n into summation of k equals 1 to n into 1 plus k upon n times ln of 1 plus k upon n. So this is your expression. Now you take the first two terms together, which means you group the first two terms, and in that you can see that ln n is a common term. So you can write this as ln x is equal to ln n is common times minus 3 by 2 plus 1 upon n, summation of 1 plus k upon n, so which is summation of 1, which essentially will become n, k equal to 1 to n, plus summation of k equals 1 to n of k by n, plus 1 upon n times summation of k equals 1 to n times 1 plus k by n times ln of 1 plus k by n. So simplify this, you get ln of n times minus 3 by 2 plus 1 upon n, and then you have summation of 1 n times, so you get n here, plus 1 by n into summation of k, which gives you n into n plus 1 by 2 plus 1 upon n, summation of k equals 1 to n times 1 plus k upon n ln of 1 plus k upon n. So simplifying the first part, you get minus 3 by 2 plus 1 upon n into n gives you a 1, then this cancels out, so this is 1 upon n times n plus 1 by 2, so which is n by 2 plus half into 1 by n, so that is plus n by 2n plus half into 1 by n, so 1 by 2n plus 1 by n, summation of k equals 1 to n, 1 plus k upon n ln of 1 plus k upon n. So then this one becomes n and n cancels, so 1 by 2 minus 3 by 2 is minus 1, and this is plus 1, so this one will cancel with 1 and half, and you get into 1 by 2 upon n plus 1 upon n times summation of k equals 1 to n into 1 plus k by n ln of 1 plus k by n. So this is the expression. Now as n tends to infinity, ln n by 2n will tend to 0. So the first term goes to 0. So you get limit n tending to infinity of ln x is limit n tending to infinity of 1 upon n times the summation of k equals 1 to n into 1 plus k by n ln of 1 plus k by n. So now the right hand side can be written as an integral, which is integral of 1 to 2 x ln x dx. So this can be integrated by parts. So where we take ln x as u and x dx as dv. So therefore du becomes 1 by x dx and v becomes x square by 2. So integrating by parts, you get u into v, which means ln x into x square by 2, x square by 2 times ln x minus v du, which is integral of 1 to 2. Now this will be from 1 to 2, and the second part would be from 1 to 2 v du. So x square into 1 by x by 2 dx. So x square by 2 into 1 by x dx. So this simplifies. So the first part becomes 4 by 2 ln 2, 4 by 2 ln 2 minus 1 by 2 ln 1 minus the second integral is x by 2 dx. So which is 1 by 2 integral x dx, which is x square by 2 from 1 to 2. So therefore your expression becomes 4 by 2, which is 2 ln 2 minus 0, that is 0, and then the second part becomes minus half, or rather minus 1 by 4 times x square, which is 4 minus 1. So this becomes 2 ln 2 minus 3 by 4, which can be written as ln of 4 2 to the power 2, which is ln of 4 minus e to the power ln of e to the power minus 3 by 4. This will be a plus. So this becomes equal to ln of 4 e to the power minus 3 by 4. So therefore the left hand side of the integral is ln of x n tending to infinity of x is this. So ln of limit n tending to infinity of x is this. So which is what we wanted. So therefore limit n tending to infinity of x is 4 into e to the power minus 3 by 4. Now if we look at the options given, this is option number 4 or D. Now we go to question number 11. This one says x and y are positive integers and 4x plus 3y and 2x plus 4y, when divided by 7, the remainders are 2 and 5. What is the remainder when 11x plus 5y is divided by 7? So we write this as 4x plus 3y is 2 mod 7 and 2x plus 4y is 5 mod 7. Now from this we want to eliminate either x or y. Now it's easy to eliminate x because if we multiply this with 2 and subtract the first one, then x will be eliminated. So if I do that, I will get 4x plus 8y is 10 mod 7, which can be written as 3 mod 7, and 4x plus 3y is 2 mod 7. So if I subtract this from the first one, I get 5y equals 10 minus 2, which is 8 mod 7, which can be written as 1 mod 7. So 5y is 1 mod 7. So I can write 15y as 3 mod 7. Now 15y is equivalent to y because this is 14y plus y. Now 14y is divisible by 7. So this becomes equivalent to y. So y becomes equal to 3 mod 7. Now I have got the value of y. This is 3 mod 7. Now I can find the value of x by substituting this in any of the equation. We can put it in the second equation. So 2x plus 4y is 5 mod 7. So 2x plus 4 into 3. So 4y is 4 into 3 mod 7 equals 5 mod 7. So 2x plus 12 mod 7 is 5 mod 7. So 12 mod 7 is can be written as 5 mod 7. So 2x plus 5 mod 7 equals 5 mod 7. So 2x is equal to 0 mod 7, or x is equal to 0 mod 7. X is equal to 0 mod 7. So now we got x and y, and now we can find the value of 11x plus 5y. So 11x plus 5y is 0 mod 7 plus 5 times 3, which is 15 mod 7, which is 1 mod 7. So which means that when 11x plus 5y is divided by 7, the remainder is 1. So the answer for this would be 1, which is option